this lesson, we're going to talk about partitioning a segment. So first of all, what it means to partition a segment, it means that you're going to divide it up into pieces. So if you see partitioning a segment, it means you're going to break that segment up into pieces. So the next thing that you have to know is what's called a directed line segment, and that's just a segment that's from one point to another point on the coordinate plane, and it's in a specific direction. So for example, directed line segment AB starts at point A and it ends at point B. So the direction matters when we say a directed line segment. So for example, if I switch this, I said BA, it would mean you're starting at B going to A. So that's going to be important for these problems. Normally, we say it doesn't really matter if you say AB or BA. But for these problems, you can, it does matter because you're going to see we have to break it up into a specific ratio. So the direction does matter. So if we look at example 1, we have point P is partitioning directed line segment AB. So that means we're starting at point A, we're ending at point B. And we're going to break it up with point P, this segment. And here's our coordinates. We want to break it up into a 1:3 ratio. So whenever you see ratio, just to kind of review that, 1:3, this is red 1:3. The little colon means 2. So this means that it's really 1 part to 3 parts. So total, if I'm breaking something up into a 1:3 ratio, it really means that I'm breaking it up into 4 parts. So there's a total of 4 parts. So just to kind of sketch a picture of what this is going to look like, if I start with point A, because it's a directed line segment, it means that I'm going to put point P so that segment AB is broken up into 1:3 parts. So after 1 part, I would have point P, and then there's going to be 3 more equal parts, and that's where point B is going to go. So this is a 1 part to 3 part ratio. And point P is the point that's partitioning it. It's dividing it up. So my goal here is to figure out the coordinates of point P. So that means I know A and B. So I know between A and B, since there's 4 parts, that means there's going to be 3 coordinates. There's going to be point P, which is what I want, and then there's going to be these other 2 coordinates in between A and B. So graphically, I'm going to show you, but graphically is not going to always work because there's decimals, but I want to at least show you that first, and then we'll look at how to do this algebraically. So graphically, go ahead and start with plotting your points. -2, -5, so 1, 2, 3, 4, 5. It's really important that you're labeling your points here. B is going to be 6, 1, so 1, 2, 3, 4, 5, 6, up 1. And this is my segment that I want to break up into 4 parts in a 1:3 ratio, and I want point P to be the point that makes it the 1:3 ratio. So it's going to be very similar to the midpoint process that we did, where you're going to count that distance to get from A to B. A midpoint divides a segment into 2 equal parts, so you would cut that distance in half. But for this, I want it to be divided into 4 parts in a 1:3 ratio. So instead of cutting it in half, the segment, since I'm dividing it into 4 parts, I'm going to divide that distance by 4. So I'm going to start by counting. So 1, 2, 3, 4, 5, 6. So I'm going up 6, and then I went right. So starting here, 1, 2, 3, 4, 5, 6, 7, 8. So I'm dividing this by 4 because I need to break the segment up into 4 equal parts. So divide each of these by 4. So that means you're going to go right 2 for each point. And dividing this by 4, 6 divided by 4 is going to be a decimal, which tells me I'm going to be going up 1.5 because it reduces down to 3/2. So when you do this, you can kind of see already that decimals aren't going to be the best for graphing, which is why I'm going to show you algebraically. But for 0.5, you can kind of estimate that easy enough on a graph. But if you get something like 0.1, 0.2, that's going to be definitely more difficult on a graph. So I'm going to show you algebraically after. So going up 1.5, so up 1.5, and then over 2. Then I'm going to go up 1.5 over 2. up 1.5 over 2, up 1.5 over 2. I should end up back at B. So now I've divided my segment up into 4 equal parts, and point P is going to be this first coordinate because that would make this a 1 to 3 part segment. So point P, the coordinates of that are going to be 0, and then it's down 1, 2, 3.5. So it's going to be 0, comma, negative 3.5. So that's on a graph. Like I said, sometimes you're not going to be able to do it on a graph. So let's take a look at how to do it algebraically. So algebraically, so I'm just going to write, this is graphically, obviously on a graph. And then algebraically will be over here. So algebraically, when you do this, you're going to line up your coordinates just like we do for the midpoint when we're trying to find the other endpoint. It's going to be very similar to that. So we're going to line up our coordinates, and I always recommend drawing this picture here that we started with because that's going to tell you how many coordinates you have between points A and B. So I'm going to start with coordinate A, so that's my first one. I'm going to draw this basically vertically. So starting with A, my coordinates are -2, -5. Then I'm going to have 3 coordinates between A and B. So I'm going to have 1, which is going to be point P. So I'm just looking at this. I'm going to leave that empty because I don't know what it is. Then I have a second coordinate. I don't know what that is, so I leave it empty. Third coordinate, I don't know what that is. And then the last one is point B, which was given to us. So I just listed all these vertically. Point B is 6, 1. And now what you're going to do is basically the same thing that you did on a graph, but instead of counting the distance, you're going to actually figure out the distance that you, by addition and subtraction. So what you want to do is you want to look at, well, how did I go from A to B? So you have to look at how did I change the x values? So how did I go from -2 to 6? So -2 became positive. It means you're going to be adding something to it. So I'm going to be adding 8 to it. So if you needed to, you could do this on a number line and count, or you could even graph it and just figure out, well, how did I move from A to B horizontally? Well, I went 8 to the right, which means it's +8 to the x values. So that's the total change from the x's. And if you remember, we had to divide that because we're breaking the segment into 4 equal parts. So you have to divide that distance by the number of parts. So 4 parts means it's +2 each time. We move to the right 2 each time. So instead of moving to the right on the graph, you're just going to add 2 to your x values. Add 2, you get 0. Add 2 again, you get 2. Add 2 again, you get 4. Add 2 again, it should always end up at point B. So that's how you would do your x values. You're going to do the same thing, but for the y values. So how did I go from -5 to 1? Well, it became positive, so you had to add to it. So you would have to add 6 to it, which if you remember over here, so if you're struggling coming up with that +6, graph it and just count. I had to go up 6. So since you go up 6, it means +6 for y. So +6, and there's 4 parts. So divide that out, you get 1.5. So now that means I'm adding 1.5. So -5 plus 1.5 gives me -3.5. Add 1.5 again, you get -2. Add 1.5 again, you get -0.5. And then add 1.5 again, and you get 1. So that's how you know you've done it correctly. Now the answer is going to be the point that they asked for that divided it into a 1 to 3 ratio. So the answer is going to be point P. So you would just want to make sure you state that somewhere. So point P is 0, -3.5. And you can see we got the same answer both times. But like I said, you have to know how to do this algebraically because you're going to see numbers that won't work as nice on a graph.